When we talk about observations in physics, we have to have a way of understanding observations across the scientific community, across the world, essentially. And to do that, we measure things, we measure our observations using particular units. We call these things fundamental units. For example, if someone asks you how tall you are, you're not going to tell them you're 73. That doesn't make any sense. You're going to tell them you're 73 inches tall, or you're 6 foot 1 inch tall, or 6 feet 1 inch tall. So you have a number associated with that measurement, but you also have a unit of inches or feet, and you know how to compare that unit to something else. In every science, and particularly in physics as well, every measurement should have a number, an amount, a magnitude, as well as a unit associated with it. Science uses a particular system of fundamental units. There are a few fundamental units in science. For now, we're just going to talk about 3 of them. The fundamental unit for time is seconds. The fundamental unit for length is meters. And the fundamental unit for mass is kilograms. Now, the way that science can make this universal across the world and everywhere else is that we have a particular way that we define these fundamental units. For example, in the past, the amount of time that was 1 second was determined by the length of a day, the length of time that it took for the Earth to revolve on its axis, 1 complete revolution, or 1 complete rotation. However, now, science has found a way to link time as well as the other fundamental units to physical constants that have been measured in the universe. For example, now the second is measured using an atomic clock based on the oscillation of cesium atoms. And these oscillations are so accurate that they lose only 1 second every 1.4 million years. The definition of the meter was originally tied to the distance from the equator to the North Pole. But since now we understand that the speed of light is a physical constant, we can use the speed of light to determine what would be the length of 1 meter, is then the distance that light can travel in a vacuum in 1 over 299 million seconds, approximately. The kilogram was the final fundamental unit on the list to receive an atomic definition. Initially, the kilogram was based on a particular metal cylinder that was held in a lab or museum in France or somewhere in Europe. Recently, the scientific community agreed to change the fundamental measurement of a kilogram to be based on a value known as Planck's constant, which is the smallest fundamental unit of energy. There is an energy and mass relationship, and that is why a unit of energy can be used to determine a kilogram.